Good day and welcome you all to this very brief introductory session of NPTEL online certification course on fluid machines. The course is a first level course on the subject fluid machines. Fluid machine is a device that converts potential or stored energy of the fluid into mechanical energy and vice versa. The stored energy of a fluid usually appears in the form of potential energy, kinetic energy and intermolecular or thermal energy by virtue of its temperature, while the mechanical energy is transmitted by a rotating shaft. The machines where the mechanical energy is obtained as the output and the stored energy is given to the machine as an input are known as turbines. And depending upon the fluid used, they are classified as hydraulic turbines that use mostly water as the working fluid, steam turbines that use steam as the working fluid, and gas turbines that use gas, which is a mixture of air and the products of combustion by burning the fossil fuels for this purpose as the working fluid. On the other hand, the machines which absorb mechanical energy or takes mechanical energy as input and delivers the stored energy of the fluid mostly in the form of high pressure or high velocity are known as pumps, compressor, fans and blowers. There is not any generic name for this. Pumps are machines which handle water or any liquid, while compressors handle or use air as the working fluid, and both the compressors and fan and pump, they deliver the stored mechanical energy in the form of fluid pressure. Fans and blowers, they use air and deliver the stored energy of the fluid in the form of high velocity. Now, the underlying principles of operation of these machines lies in the rate of change of angular momentum of a fluid due to dynamic action of a number of rows of moving blades. This happens in course of a continuous flow of fluid through the blade passages comprising the blade rows, which are attached or mounted on a rotor and execute a continuous rotating motion. Now, the fluid machines has wide applications in almost all fields of engineering. The major applications pertain to electric power generation, aircraft and rocket propulsions, and in a variety of small and medium industries. For example, as we know, the turbines, hydraulic turbines, steam turbines and gas turbines, they are used in power plants and they are one of the most important components, is power producing components of the power plant. Apart from this use, compressors are used in aircraft propulsions or aircraft engines. There are two types of compressors which will be dealt further in details: centrifugal compressors and axial flow compressors. In centrifugal compressors are used for low speed aircraft engines, while the modern high speed aircraft engines use axial flow compressors. Beyond that, in almost all industrial applications where compressed air is needed, air compressors are used. On the other hand, we see that in all fields of engineering, the circulation of water or any liquid, flow of water or any liquid, the transmission and distribution of water or any liquid are always involved with. and therefore, the pumps get their widespread applications in all those industries. Hence, we see that fluid machines in general, turbines, compressors, fans, blowers, pumps are largely used or have widespread use in almost all fields of engineering, starting from very routine industrial uses to the very important industrial uses like generating electrical power, to the applications of high technology uses like aircraft and rocket propulsions. Now, this course, as I have told, is the first level course on fluid machines, and will emphasize the underlying fluid mechanical principles in governing the energy, in governing the such energy transfer in the machines, that is from stored energy of the fluid to mechanical energy, or from mechanical energy to stored energy. And on the basis of these fluid mechanical principles, the operations of different fluid machines, hydraulic machines and the machines using air will be described along with their performance characteristics. More emphasis will be given on the physical concepts and understanding along with their relevance in practice. The coverage of the course will have a balanced components, will have balanced components of physical concepts, mathematical operations, and worked out and exercised problems of practical importance. After this course, after studying this course, the students will be able to apply the laws, the principles and the basic equations to the engineering design of such machines for required applications. And at the same time, the students will acquire an adequate prerequisite, adequate and strong prerequisite I will say, for pursuing a second level or advanced level course on fluid machines, to acquire more knowledge to bring about an innovative technological change in fluid machines, to have compact machines with much higher efficiencies and more environment friendly. Okay? Thank you.